Well, hi, Geometry. Welcome to Chapter 12, the last chapter in the book. We may or may not hit Chapter 9 that we skipped. That's matrices. We'll see, but I would like to hit it. Here we go. Our learning targets. I can find a sample space and their probabilities, and I can find the likelihood of an event. So there's a lot of notation you're going to have to learn here. And also, there should be a lot of review from your middle school math days. So here we go. Use a tree diagram to find, apparently I did not proofread these, the number of possible outfits you can make if you have 3 shirts and 4 pair of pants. Well, we have 3 shirts and 4 pair of pants. Usually I start with a number that's like larger of how many we have. So I'm going to say pant 1, leave space in between, pant 2, pant 3, pant 4, and then we have 3 shirts off of each one. Shirt 1, shirt 2, shirt 3, and last, there's your tree diagram. Now, I did make this vertically. Most of my tree diagrams are like horizontal, but it was a space issue here. So, let's see. Oh, that's not any better. Okay. And what this means is, if I were to circle this one, that means you picked pant 2 with shirt 3. And also, how many possible outfits do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 outfits. All right. How about this? List the number of possible ways to hit all 9 Subway sandwich shops that we have here in Kenosha. Yes, we have that many. All right. Well, how many choices do you have for the first one? We have 9. And once you've gone to that first Subway shop, how many do we have left? Then 8, 7, 6, 5, 4, 3, 2, 1. And what we're going to do is we're going to multiply these. Now, there is some notation that you may or may not have heard of. It's this. N factorial. It doesn't mean 9. And there are keys in the calculator to help you find that. Okay, let's see if we can actually do this. So I'm going to press 9. It's not even going to work. Let me turn off this light above me. Okay, I don't think it's going to work. It's light out, and I usually like to do these at night, but it's not getting light till later. Alright, so there's a 9 there. There it is. Okay, there's a 9. And I'm going to press Math. And then go over to PRB. That's probability. And go down to number 4. That's the factorial symbol. Press Enter. You'll see 9 factorial. Enter. That's how many ways? 362,880. So in the calculator, you're going to type in 9, then you press Math. You're going to go over to PRB. You're going to go down to number 4, which is factorial. Then Enter. So we have 362,880 different routes you could take to hit all of your Subway sandwich shops. All right. So, probability of an event. Any happening for which the result is uncertain is called an experiment. This just seems weird, worded weird. The possible results of experiment are called outcomes. For instance, if you flip a coin, that's an experiment. The outcomes are heads or tails. The set of all possible outcomes of an experiment is the sample space. For instance, the sample space of rolling a die would be 1, 2, 3, 4, 5, 6. A subset of the sample space is called an event. So you roll a die, you get roll a 2, so that's just a subset. There we go. Find the sample space of an experiment using one fair coin. We usually always say fair, it's not weighted on one side. And it's being tossed, and a fair 6-sided dice being rolled. All right, so I'm going to do this one horizontally here, and there's 6 sides, and then this has 2 choices. This has 6, so you usually start with the larger one. 1, 2, 3, 4, 5, 6. Also, you can go across if you want. Heads, tails, heads, tails, heads, tails. Same thing. Ooh, let's keep it. I don't know why I always gather this to a point, kind of like where you start. All right, so if I were to circle this one, that means you have a 3 heads. All right. Here we go, probability. Okay, I have some typos here. I used my notes from pre-calc with this, and we always said event E, but I changed it to event A. So I forgot. I don't know. I thought I got rid of these E's and changed them all to A's. I mean, I did it here, but who knows what happened. So if an event A has the number of A equally likely outcomes, and its sample space has n sub n of s, number of sample spaces equally likely outcomes, then the probability of event A is the number of A's you get out of the number of your possibilities, your space. All right, for instance, if I said, what's the probability of rolling an even on the die? Okay, you know, a single dice, a single die. How many evens are there? There's 2, 4, 6. So there's 3 out of 6 choices. And they'll reduce to 1/2. Okay, so if you are keeping it in fractional form, please reduce them. All probabilities will be between 0 and 1. A probability is equal to 0 if it's impossible. Like, what's the probability that you're not going to graduate 8th grade? I think that's impossible. I think you both will. And then what's the probability that you will graduate? 1, which is 100%, if that must occur. The complement of event is not A. It can look like this, not A, a bar over it, and I've also seen it with a little asterisk. So those are all not A. So we have an 80% chance of rain tomorrow. What's the probability that it won't rain? So not rain would be 20%. And that's the one thing I want you to see here. Not A is going to be 1 minus that. These two will add up to give you 1 whole. All right, next page. Yeah, I probably should have proofread these. Sorry about that. Okay, example 2. A single card is drawn from a deck of playing cards. And I actually listed out stuff in playing cards because I just discovered that a lot of students don't play with cards, and I find that interesting. You have 52 cards in a deck, 2 colors, red and black, so that means there's 26 of each color. You have 4 suits called hearts, diamonds, clubs, and spades. That means there's 13 each. There's 26 each, and there's 52. And there are 13 cards in each suit, so an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So what's the probability of drawing a king? How you make that look would be this. Probability of a king would be, how many kings will there be? There'll be 1 for each suit. 4 out of 52. And that reduces to 1 out of 13. And you can leave them as fractions, reduced fractions, or you can find the decimal. Of course, I'm rounding this, so I put a wave. What's the probability of drawing a club? Well, there's 13 in each suit, so probability of a club equals 13 out of 52. That's 1/4, which is equal to 0.25. So it's a 25% chance. So you're going to get a little bit of workout with your percent, fraction, decimal stuff. All right, so 2 6-sided die are tossed. So you can get like a 1, 1, 1, 2, etc. And one thing I want to point out, look at this. I like to do this just to kind of separate things. All of these I'm circling add up to 7. Okay? It just kind of makes sense, so you don't get really confused with this, but here we go. What is the probability that the sum, the total, is 4? All right, well, I did this on purpose because I want you to see that the diagonals are all the same value. So I want the sum of 4. Look at this. That would be this one, and this one. There's 3 of these out of 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, out of 36. And that reduces to 1/12. I don't know what the decimal is. What is the probability that the total is less than 7? Well, there's a reason why I picked the 7. So then we'll count how many are less than this. Notice it doesn't say less than equal to. If it did, I would have to include all the red, but less than. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So probability that the sum is less than 7, I said was 15 out of 36. All right. Start practicing reducing your fractions. If you don't know how to do that, or if you don't remember how to do that, it's not going to be helpful. Sorry about these videos. You know, so much for these LED screens. Remind me to show you how to reduce a fraction in the calculator if you don't remember. You'll have to take 15 divided by 36, enter, then you press math, enter, enter. So I know 3 goes in each one of these, so 5/12. What is the probability that the total is greater than 3? Okay, well, I think you should do this instead. I'm going to take 1 minus the probability that it's less than or equal to 3. Okay, so the reason for it is because there's not that many here. And greater than 3 and less than or equal to 3 would be all of them. So if I take 1 minus that, it's a little bit easier to add up. So greater than or equal to 3, that would be 1, 2, 3. 1 minus 3 out of 36. Well, 1 is the same as 36 out of 36. So 36 minus 3 would be 33 out of 36, and that reduces to 11/12. So you can just go ahead and add all of them up that are greater than 3, but this was a lot easier. Theoretical probability versus experimental probability. Okay, well, theoretical is what should happen. Okay, so if I'm flipping a coin, what's the probability of getting a heads? It should be 1/2, because you have just 2 choices. You're going to pick 1 out of 2. But have you ever flipped a coin like 100 times and it keeps coming up tails, 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 tails? I mean, that happens once in a while, but that's your experiment. So experiment is you actually did this. And this is what it should be. So technically, if you're doing an experiment and it seems to be really skewed, then take a look at your coin. Did somebody take clear fingernail polish and put lots of layers on one side so you don't notice, so it's like heavier, or just do the experiment 1,000 times. If you do it 1,000 times, there's something called the law of large numbers. Basically, law of large numbers, regardless of what's happening, is you'll eventually get to your theoretical probability. So let's take a look at some of this. Okay, now this is, they call this a two-way table. And lots of times they will leave it blank and you have to find the total. So if that's the case, okay, this is a department store. It has lots of different sunglasses. Some would have green, brown, or gray lenses. Some lenses are polarized, some are mirrored. So how many green lenses do we have? 15. Brown lenses, 13. Gray lenses, 12. And how many polarized do we have? 18. And how many mirrored? 22. And there's a total of 40 glasses. Okay, so we actually had to fill this out to answer part A. How many pairs of sunglasses were on the table? 40. Okay, not a big deal. Now, what is the probability that you choose a polarized lens? So let's say we just, at random, you're picking a pair of glasses, you grab them off the table. How many polarized lenses do we have? 18. So the probability of polarized is 18 out of 40. Divide each bolt by 2. 9 out of 20. What's the probability that you choose a brown lens? We have total of brown lens, 13 out of 20. So hopefully you're understanding that, why fractions sometimes a little easier, but if you get stuck on reducing the fraction, use the calculator or just find the decimal equivalent. Okay, odds. Odds for and against. Okay, so odds of an event comparable to the numbers of favorable and unfavorable outcomes when all outcomes are equally likely. For instance, jelly beans. Okay, because Easter is coming up this weekend, and I do not like the black jelly beans. What are the odds of getting that? What are your odds in favor? So, what you would have to do is find the probability of getting the black jelly beans divided by the probability of getting all the others. That would be the odds in favor of getting the black jelly bean. But what are the odds against? Flip it. Okay? Now you're going to find it's kind of interesting that I chose this graph. It turns out different if I use a different graph, and you'll understand why in a second. So each section of the spinner has the same area. I picked this because it says red. I print this off my husband's printer. This says orange. Purple. This is yellow. So much for his ink. He's trying to get rid of it. And green. Yeah, so I picked this graph just because when I photocopy black and white, it'll come out like that. So find the odds against green. So odds against, we have to do unfavorable. Okay, so we want not green. So how many are not green? 1, 2, 3, 4 out of 5. And then favorable for green. How many greens are there? 1 out of 5. You don't divide fractions. You multiply by the reciprocal. 5s cancel. 4 to 1. Oh, 4 to 1. Okay, find the odds for. So in favor of. Red. Okay, so how in favor of we have odds in favor. So there's 1 red out of 5. And divide by unfavorable, so we have 4 out of 5 they're not. The 5's reduced, you get 1 to 4. Okay, so I'm not going to teach you how to gamble. Okay, moving on. Almost done. Almost done. All right, same graph. And again, I picked that graph, and you'll see that it would change if there were lots of different, like a whole variety of this, but oh well. Okay, each section of the spinner has the same area. Now we're going to spin this 30 times, and let's say 7 popped up, or red popped up 7 times, orange popped up 8, purple 6, etc. Now, for which color is the experimental probability the same as the theoretical probability? Okay, so let's look at the theoretical for each color. Each area is the same, so what's the probability of getting a purple? Well, there's one purple out of 5. Okay, well, what would that be if we were going to spin it 30 times? Okay, basically it's an equivalent fraction. If you multiply bottom by 6, multiply top by 6. Which one of these was 6 times? Alright, I didn't think it was purple. I didn't do the problem ahead of time. Okay, so probability of purple has the same theoretical and experimental. So they did the experiment, and that was actually the same. So here we go. Here's our homework. And one thing that's going to be interesting is some of these sections are going to have lots of different standards because they're giving you a crash course in probability. So you're going to touch upon a little bit of everything, and you'll do a lot more of this in Algebra 2. And maybe a little bit more in pre-calc, but Algebra 2, you're supposed to get a lot of this. So in any case, have a nice evening.